Hello dear learners, I'm Zinnah. I'm a chemistry teacher. Today I'm with the topic mole. In our daily life, we measure various things in various ways. We measure things by counting, or we measure masses. We also measure volumes. And today's topic, mole, is basically a measurement by counting, but this is also closely related to mass and volume. And today I'm going to explain the concept of mole and how this concept of mole is related to counting and mass and volume. The amount of substance in mole. How many? Eggs. How many eggs? 1 dozen. Rice. How many pieces of rice? Say 1 billion. Water. How many water molecules in the glass? Puzzled. Really, if you have just a drop of water, this contains uncountable number of water molecules. Amount of substance in moles. Here got eggs again, 12 eggs. And rice, 10 to the power 6 number of rice. Water molecules, 6.02 into 10 to the power 23 number of water molecules. When 12 eggs or anything together, we call this 1 dozen. And when 10 to the power 6 number of anything together, we call this 1 billion. And when 6.02 into 10 to the power 23 of anything together, we call this 1 mole. But this cannot be anything. This can also be tiny particles. And this number 6.02 10 to the power 23 is discovered, is estimated by Avogadro. So this number is also called Avogadro number. And here you get 3 sets or 3 packages. First one is small package, contains only 12. We call this 1 dozen. Second one is another package, contains 10 to the power 6. We call this billion, 1 billion. And the third is a big package, 6.02 into 10 to the power 23. We call this 1 mole. These 3 are similar because they are packages of different number. The amount of substance in mole. So when you have 6.02 into 10 to the power 23 or Avogadro number of molecules together, you call this 1 mole of water. When you have Avogadro number of oxygen molecules together, you call this 1 mole oxygen. And when you have Avogadro number of carbon dioxide together, what do you call this? 1 mole carbon dioxide. And how many ions together? You call this 1 mole of sodium ions. And if you have double than Avogadro number of oxygen molecules together, what you will call? How many moles there? 2 moles of oxygen. Good. And how many molecules together you will call? 0.5 mole of nitrogen. Compare dozen and mole. Here's 1 dozen and here's 1 mole. How many people? 12 people. How many dozen of people? You will call this 1 dozen of people. This is the package. How many molecules? 6.02 into 10 to the power 23 number of molecules. But how many mole of molecules? You would say the package 1 mole molecule. But see here, one person has 2 hands. So when you have 12 people together, certainly 12 into 2 hands. And 1 water molecule contains 3 atoms. And Avogadro number of water molecules contain 3 times more atoms. How many dozen of hands of the people? 2 dozens, because 2 into 12 is 2 dozens. So you get 1 dozen people have 2 dozen hands. How many atoms of the molecules? 3 into Avogadro number of atoms. And how many mole of atoms? 3 moles. And 1 mole water equals 3 mole atoms. Exercise. 1 mole of hydrogen contains Avogadro number of hydrogen molecules. And this contains how many hydrogen atoms? Double number of hydrogen atoms, because each one contains 2. So double number of hydrogen atoms, double than Avogadro number, will have 2 moles of hydrogen atoms. Here you get 1 mole hydrogen chloride contains Avogadro number of hydrogen chloride molecules. This contains how many hydrogen atoms and how many chlorine atoms? Avogadro number of hydrogen atoms and Avogadro number of chlorine atoms. And Avogadro number of hydrogen atoms equal 1 mole hydrogen atoms, and Avogadro number of chlorine atoms equal 1 mole chlorine atoms. Together is 2 mole atoms. So 1 mole of hydrogen chloride contains Avogadro number of hydrogen chloride molecules, and that contains double number of atoms, and that equal 2 mole of atoms. 1 mole of water contains Avogadro number of water molecules, and how many hydrogen atoms and oxygen atoms are there? How many moles of hydrogen and oxygen atoms are there? How many moles of atoms are together? And from the concept of moles, we're going to discuss 2 other things closely related to moles. These are molar mass and molar volume. These 2 terms both contain mole. So we say molar mass and molar volume. Let's see how these 2 are related to mole. Mole, molar mass and molar volume. 1 mole of hydrogen contains Avogadro number of hydrogen and molar volume. If 1 mole of this hydrogen gas is together in a container, this occupies a volume. So this volume occupied by 1 mole hydrogen gas. So we call this molar volume. And this is 24 dm cube at RTP, room temperature and pressure. And if you want to measure its mass, you will get molar mass, because you are measuring the mass of Avogadro number of molecules, or 1 mole molecules. So this is called molar mass. More about molar volume. 1 mole hydrogen contains Avogadro number of hydrogen molecules, and if this is placed in a container, this occupies molar volume. And if this is 1 mole carbon dioxide, this equals Avogadro number of carbon dioxide. And if this is placed in another container, this will occupy another set of volume. Interestingly, this is also 24 dm cube. So molar volume of hydrogen is 24 dm cube, and molar volume of carbon dioxide is 24 dm cube. What do you get? For any gas, molar volume is 24 dm cube or 24,000 cm cube if this is measured at 25 degrees Celsius and 1 atm pressure. More about molar mass. 1 mole hydrogen contains Avogadro number of hydrogen molecules. If this is placed in a container, this is molar volume. And if you measure its mass, you are measuring mass of 1 mole substance. This is molar mass. Molar mass of hydrogen is 2 gram. And if this is 1 mole of carbon dioxide, this is Avogadro number of molecules. If this is placed in a container, this is molar volume. And if you measure its mass, you are measuring mass of 1 mole carbon dioxide, Avogadro number of molecules. So this is molar mass of carbon dioxide. This is 44 gram. Molar mass of different substances are different. the value of molar mass of a substance is same as its relative mass, but they are different. Differences between relative mass and molar mass. Relative formula mass of carbon dioxide is 44 and molar mass of carbon dioxide is 44 gram. So you get numerically they are same, but they are different. Relative formula mass and molar mass. Get the differences. Relative formula mass is the mass of a single particle, but molar mass is the mass of 1 mole or Avogadro number of particles. Relative formula mass is measured in carbon scale, whereas molar mass is measured in real scale, in gram. Relative formula mass doesn't have any unit, it's a ratio, but molar mass has units, it's gram per mole. So these were all about the concept of mole, molar mass and molar volume. I hope this video has made your concept of mole, molar mass and molar volume very clear, and I'm happy to be with you. Thank you.